According to the electrical code concerning hydromassage tubs, specifically Article 680.74, some confusion can arise regarding bonding requirements. The correct answer is that both the metal piping on a tub that is in contact with circulating water and the metal piping that supplies water to the tub need to be bonded together by a #8 American wire gauge copper conductor. Article 680.74 addresses bonding for hydromassage bathtubs. A key point to understand is the change in the National Electrical Code, (ONEC), regarding listed double-insulated pumps. The requirement to bond internal, non-current carrying metal components of a listed double-insulated hydromassage pump has been omitted. This change was implemented because bonding these internal components would violate the listing of the pump itself. The reasoning behind this is that listed double-insulated pumps are designed with enhanced safety features that negate the need for additional internal bonding. These pumps typically have a 3-wire cord including an equipment grounding conductor, providing a sufficient level of safety. Therefore, the focus shifts to bonding external metal components that could become energized, posing a shock hazard. Metal piping that is in contact with circulating water within the tub is a prime example. This piping could potentially become energized due to a fault within the pump or other electrical components. Bonding this piping ensures that any fault current is safely conducted back to the electrical panel, tripping the circuit breaker and de-energizing the circuit. Similarly, the metal piping that supplies water to the tub also needs to be bonded. This is because the water supply piping is often connected to the building's grounding system. Bonding the supply piping to the tub's bonding system creates a continuous electrical path, ensuring that any potential difference between the piping and the tub is minimized. This reduces the risk of electric shock should a fault occur. To reiterate, the specific requirement is to use a #8 American wire gauge copper conductor to bond these components. The #8 American wire gauge wire size is chosen to provide a low impedance path for fault current, ensuring that the circuit breaker trips quickly and effectively. The bonding connections should be made in accordance with the electrical code, using approved bonding methods and connectors. It's important to note that this information is based on specific electrical codes and standards, such as the NEC. Local codes and regulations may vary, so it's always best to consult with a qualified electrician to ensure that your hydromassage tub installation meets all applicable requirements. Let's break down why the other options are incorrect. Option states that internal non-current carrying metal components of a listed double-insulated hydromassage pump are required to be bonded. As previously explained, this is incorrect because bonding these internal components would violate the listing of the pump. Double-insulated pumps are designed to be inherently safe, and additional internal bonding is not necessary and can actually compromise their safety features. Option B states that metal piping on the tub that is in contact with circulating water needs to be bonded. This is partially correct, as this piping does need to be bonded. Option C states that metal piping that supplies water to the tub needs to be bonded. This is also partially correct, as this piping also needs to be bonded. However, options B and C are not the complete answer. Option D combines options B and C, stating that both the metal piping on the tub that is in contact with circulating water and the metal piping that supplies water to the tub need to be bonded. This is the correct answer because it includes all of the components that are required to be bonded. In summary, when installing or maintaining a hydromassage tub, it's crucial to understand the bonding requirements to ensure electrical safety. Remember that listed double-insulated pumps do not require bonding of their internal components, but the metal piping in contact with circulating water and the metal piping supplying water to the tub must be bonded together using a #8 American wire gauge copper conductor. Always consult with a qualified electrician to ensure compliance with local codes and regulations. The electrical code stance on bonding hydromassage tubs is intended to protect against electrical shock hazards. By properly bonding the metal components, you create a safe and reliable electrical system for your tub. The National Electrical Code Article 680 covers electrical installations in and around swimming pools, spas, hot tubs, and hydromassage bathtubs. This article provides specific requirements for bonding, grounding, wiring methods, and equipment placement to minimize the risk of electrical shock. When working with electrical installations near water, it is imperative to follow these requirements meticulously. Grounding and bonding are two distinct but related concepts in electrical safety. Grounding refers to connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding refers to connecting different metal parts together to create a continuous electrical path. In the case of hydromassage tubs, bonding is crucial to minimize voltage differences between metal components, reducing the risk of electric shock. The #8 American wire gauge copper conductor used for bonding is sized to handle the expected fault current. The larger the wire gauge, the more current it can safely carry. Copper is chosen as the conductor material because it is an excellent conductor of electricity and is resistant to corrosion. When making bonding connections, it is important to use approved connectors that are designed for the purpose. These connectors ensure a reliable and low impedance connection. Avoid using methods such as wrapping the wire around the pipe and taping it, as these methods are not reliable and can corrode over time. In addition to bonding the metal piping, it is also important to ensure that the electrical panel and all electrical equipment associated with the hydromassage tub are properly grounded. This includes the pump motor, heater, and any other electrical components. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. The equipment grounding conductor, or EG, is the wire that connects the metal parts of electrical equipment to the grounding system. The EGC is typically a green or bare copper wire. It is important to ensure that the EGC is properly sized and connected to provide a low impedance path for fault current. When installing wiring for a hydromassage tub, it is important to use the correct wiring methods. The wiring must be suitable for wet locations and must be protected from physical damage. Conduit is often used to protect wiring from damage. Conduit is a metal or plastic pipe that is used to enclose and protect electrical wiring. There are different types of conduit available, such as rigid metal conduit, electrical metallic tubing, or IMT and PVC conduit. The type of conduit used depends on the application and the local codes. Ground fault circuit interrupters, or GFCIs, are required for all electrical circuits that supply power to hydromassage tubs. GFCIs are designed to detect small amounts of current leakage and to trip the circuit breaker quickly, preventing electric shock. GFCIs are very sensitive and can detect current leakage as low as 5 mA. It is important to test GFCIs regularly to ensure that they are working properly. To test a GFCI, press the test button on the GFCI receptacle. The GFCI should trip and energize the circuit. To reset the GFCI, press the reset button. The location of electrical equipment near a hydromassage tub is also important. Electrical equipment must be located at least 5 feet away from the tub, unless it is specifically designed for use in wet locations. This includes receptacles, switches, and lighting fixtures. Lighting fixtures that are installed near a hydromassage tub must be specifically designed for use in wet locations and must be ground fault protected. Low voltage lighting is often used near hydromassage tubs to provide a safe and aesthetically pleasing lighting solution. Low voltage lighting operates at a lower voltage than standard lighting, reducing the risk of electric shock. When installing a hydromassage tub, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific information about the installation requirements, including the bonding and grounding requirements. It is also important to obtain all necessary permits and inspections before installing a hydromassage tub. Permits and inspections ensure that the installation meets all applicable codes and regulations. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to install your hydromassage tub. A qualified electrician will have the knowledge and experience to install a tub safely and correctly. The importance of proper bonding and grounding cannot be overstated. These measures are essential for protecting against electric shock hazards and ensuring the safety of anyone using the hydromassage tub. Always consult with a qualified electrician to ensure that your hydromassage tub installation meets all applicable codes and regulations. By following these guidelines, you can enjoy your Hydromassage tub safely and with peace of mind. The code changes related to double insulated pumps reflect an understanding of the technology and safety features incorporated into these devices. Previously, there was a blanket requirement to bond all internal metal parts, regardless of the pump's design. However, as double insulation technology advanced, it became clear that this requirement was unnecessary and could even be detrimental. Double insulated pumps are designed with 2 layers of insulation, providing redundant protection against electric shock. The internal metal parts are isolated from the external casing, preventing them from becoming energized. By bonding these internal parts, you could potentially create a path for current to flow, compromising the double insulation system. The code change recognizes that listed double insulated pumps have already undergone rigorous testing and certification to ensure their safety. Requiring additional bonding would be redundant and could potentially void the listing. Therefore, the focus is now on bonding the external metal components that could potentially become energized, such as the metal piping. This approach provides a more targeted and effective way to protect against electric shock hazards. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other professional before making any electrical installations or modifications. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Always turn off the power before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advancements in technology and safety practices. It is important to stay up to date on the latest code requirements to ensure that your electrical installations are safe and compliant. You can purchase a copy of the National Electrical Code from the National Fire Protection Association or NFPA. The NFPA also offers training and certification programs for electricians and other electrical professionals. In addition to the National Electrical Code, there may be local codes and regulations that apply to electrical installations in your area. It is important to check with your local building department to determine the specific requirements for your location. The information contained in this discussion is not intended to be a complete and exhaustive treatment of the subject matter. It is intended for educational purposes only and should not be relied upon as a substitute for professional advice. Always consult with a qualified electrician or other professional before making any electrical installations or modifications. The use of electrical equipment and systems involves inherent risks. It is important to take all necessary precautions to protect yourself and others from electric shock, fire, and other hazards. Always follow the manufacturer's instructions when using electrical equipment. Do not overload electrical circuits. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Keep electrical equipment away from water and other liquids. Do not attempt to repair electrical equipment unless you are qualified to do so. If you have any questions or concerns about electrical safety, consult with a qualified electrician. The information provided herein is believed to be accurate and reliable as of the date of this response. However, no warranty, express or implied, is made regarding the accuracy or completeness of this information. The user assumes all responsibility for the use of this information and for any consequences arising therefrom. The speaker is not responsible for any errors or omissions in this information. The electrical industry is constantly evolving. New technologies and safety practices are being developed all the time. It is important to stay up to date on the latest developments to ensure that you are using the safest and most effective methods. You can stay informed by attending industry conferences, reading trade publications, and taking continuing education courses. By staying informed and following the proper safety precautions, you can help to prevent electrical accidents and injuries. Remember to consult with a qualified electrician for any electrical work. The metal components needing to be bonded are the ones that could become energized through a fault. This is why the circulating water pipe and the supply water pipe are the main concern. Also, remember that standards and practices can change. This information is the best available at the time of this recording.